Something has gone wrong with your print, and you do not know which of the 200 settings caused it. Here is the thing. You almost never need to guess. Nearly every print failure falls into one of 5 families: bed and first layer, extrusion, mechanical faults, surface quality, and weak parts. And they have an order. Work through them top to bottom, because a problem high on this list will fake the symptoms of everything below it. Chapter 1, the bed in layer 1. If the print will not stick at all, the nozzle is either too far from the bed or the bed is dirty. Level it at printing temperature, then set your zit offset live while the first layer goes down until the lines just squish together. And wipe the plate with isopropyl alcohol because skin oil is invisible and it is the single most common cause. If the bottom few layers flare out wider than the rest, that is elephant's foot. The first layer is being crushed. Add elephant foot compensation around 0.15 of a millimeter, or raise your zit offset in tiny steps and drop the bed temperature about 5 degrees. If the corners curl up off the plate, that is warping. Plastic shrinks as it cools and it pulls the edges up with it. Raise the bed temperature, add a brim, turn cooling off for the first few layers, and get the printer out of a draft. Fix this chapter before you touch anything else. Roughly half of all failed prints were already failing at layer 1, and no slicer setting further down will rescue a print that never stuck properly. Chapter 2, extrusion. Is the right amount of plastic coming out? Gaps between your walls, thin patchy layers, lines that do not touch. That is under-extrusion. Run a flow calibration first, because if your flow ratio is wrong, then every other number you tune is compensating for the wrong thing. Then try 5 to 10 degrees hotter. If the printer is moving but almost nothing is coming out and the extruder is clicking, you have a clog. Do a cold pull, heat it up, push filament through by hand, let it cool to about 90 degrees, then pull hard, and check your hot end fan is actually spinning, because if it stops, heat creep will jam you every single time. Fine strings between parts is stringing. Increase retraction length gradually, drop the nozzle temperature a few degrees, and raise your travel speed so there is less time to ooze. But before you tune any of that, check whether your filament is wet. Listen for popping or hissing at the nozzle, and look for a rough, fuzzy finish. Wet filament strings under-extrudes and snaps no matter what you do in the slicer. Dry PLA at 55 degrees, PETG at 65 for 4 to 6 hours. 4. The rule for this chapter: calibrate flow before you change anything else. Guessing at flow wastes filament and hides every other problem. Chapter 3, mechanical faults, the ones no setting will fix. Here is how to tell them apart from slicer problems. Mechanical faults are regular. They repeat at a fixed spacing, or they happen at a specific height every time. Slicer problems change when you change a setting. Mechanical ones do not. If the print suddenly jumps sideways and every layer above is offset, that is a layer shift. The nozzle never reached where the G-code sent it. Check the grub screws on your pulleys first because it is free and it is usually the answer. Then lower acceleration and travel speed. Evenly spaced horizontal bands running the whole height is Z banding. Spin your lead screw by hand and watch the top for a wobble. Let it float rather than clamping it rigid, and keep it clean and properly greased. Faint echo lines rippling out after every corner is ringing, and that is vibration. Drop your outer wall acceleration first. Ringing is almost always acceleration rather than speed. Then check your belt's twang instead of sagging. And if you came back to a bird's nest of plastic, that is spaghetti. The print detached and the nozzle kept extruding into thin air. That is not a separate problem. It is a first layer problem that you did not catch. Go back to chapter 1. The rule here: if a fault repeats with perfect regularity, stop changing settings. You are looking at hardware. Chapter 4, surface quality. It printed, but it looks wrong. Little blobs and bumps scattered over the surface are zits, and they are leftover pressure escaping when the nozzle stops. Get retraction roughly right, then turn on pressure advance. Pressure advance is the setting that actually solves this, because it manages pressure at every start and stop. A visible scar running up one side is the Z seam. Every layer has to start somewhere, and those start points stack into a line. Set seam positioned back or aligned so it hides in one place, and add a small seam gap. A rough or ridged top surface is fixed entirely in the slicer. Take top shell layers to 5, set the top surface pattern to monotonic, and turn on ironing for top surfaces. Monotonic plus ironing does about 90% of the work. Droopy rough overhangs need cooling and speed. Put the fan to 100% for PLA and slow your overhang speeds right down. Past about 45 degrees, each layer has almost nothing underneath it, and cooling is the only thing holding it up. Sagging bridges are the same physics across a gap. Cooling at full, slow the bridge speed so each strand sets as it crosses, and drop bridge flow slightly below 1 to thin the line. And gaps between your walls and infill usually mean your flow is off, or you need another wall loop, which takes you straight back to Chapter 2. Chapter 5, it printed perfectly and then it snapped. A 3D print is layers stacked and glued together, and that glue is the weakest direction, always. A part is strong along its layers and weak between them. So, the first fix is free. Turn the model. Work out which way the load pulls and lay the layers across it rather than along it. A hook printed lying flat is many times stronger than the same hook printed standing up. The second is walls, not infill. 3 walls at 15% infill beats 2 walls at 50%, and it prints far faster. Past about 20%, adding infill is mostly adding weight and time. And the third is temperature. Printing 5 to 10 degrees hotter melts each layer further into the one below it, which is the single biggest lever you have on layer bonding. The rule, if a part broke cleanly along a layer line, that is an orientation problem, not a strength setting problem. Chapter 6, how to actually diagnose rather than guess. Work the 5 families in order: bed, extrusion, mechanical, surface, strength, because a bad first layer will fake the symptoms of almost everything else. Change one thing at a time. If you change 5 settings and it works, you have learned nothing and you cannot repeat it. And test on something small. A 20-minute test print tells you what a 20-hour print tells you, and you find out today instead of tomorrow. Write down what worked. Your printer, your filament, and your room are not the same as anybody else's, and the numbers you find are worth keeping. So, is it sticking? Is the right amount coming out? Is the machine moving properly? Does it look right? And is it strong enough? In that order. That is the whole method. Almost every problem you will hit is on this list, and now you know roughly where to look. If this helped, subscribe to Layer Logic. There is a short video on every one of these problems if you want to go deeper on any of them.